Okay, hello everyone and welcome to our session about requirements and reuse. We are going to follow the same pattern that is going on throughout the conference. And we have a set of presentations. Every presentation will be 5 minutes and will be presented upfront in a block. And after that, we'll have time to have some discussions and questions. If you are from the audience or the presenters and would like to post questions on the chat, please prefix the question with the name of the author that you want to ask questions. And without further ado, I would like to introduce our first presenter, that is Álvaro Veizaga. Álvaro is going to talk about on systematically building a controlled natural language for functional requirements. Thank you.
Thank you. Hello, I am Álvaro from the University of Luxembourg, and I will present our first journal paper entitled On Systematically Building a Controlled Natural Language for Functional Requirements. Requirements are crucial in all software and system development projects because they state the necessary characteristics of qualities of a system. Most software requirements specifications are written in natural language. Studies confirm that 71.8% of software requirements are written in natural language. This is because natural language can be used in all application domains and understood virtually by all project stakeholders. The quality of a software system greatly depends on the quality of requirements. High quality requirements improve the system quality, the return of investments, and the customer satisfaction. On the other side, having missing, vague, inconsistent may cause projects to fail, excessive maintenance, or disappointed business users. The problem we address in this paper was motivated by practical need observed across many industrial domains. For example, our industrial partner reported us that several communication problems and delays arise from requirements that are not stated precisely enough. In this paper, we developed a controlled natural language for writing functional requirements. Remain aims at helping analysts to improve the quality of requirements. In these slides, we see our systematic methodology to define our controlled natural language consisting of 5 steps. First step, we extract requirement. Second, we identify codes and their corresponding verbs. A code identifies a group of verbs that share the same information content in natural language requirements. Third, we manually label the requirements extracted in step 1 with the codes identified in step 2. Fourth, once we have labeled all the dataset, we group requirements that share the same code to better identify common information content among requirements. Once we identify the information content of requirements, in the last step, we derive the grammar rules to build our language. For our empirical evaluation, one of the research questions was about determining how well our controlled natural language can capture requirements of previous unseen documents. To answer this research question, we conducted an industrial case study with our partner ClearStream Luxembourg. In this study, we follow an iterative process consisting of 4 steps, where the goal was to rephrase requirements that have not seen before using our controlled natural language Remain. We calculate the number of requirements that were rephrased using Remain. In the table, we can see that in average, 88% of the natural language requirements statements in 4 previously unseen software requirements specifications from the financial domain. We also kept track of the requirements that we were not able to rephrase using our controlled natural language. by annotating each requirement with one of the following three causes. Cause 1, the requirement contains a verb that is not supported by remind. Cause 2, some information content excluding the verb is not supported by remind. Cause 3, the meaning of the requirement is unclear and no financial analyst could clarify it. As conclusions, we point out the following aspects. The quality of a software system greatly depends on the quality of its requirements. Control natural languages compared to conventional requirements patterns provide structures with more specialized concepts and constructs. Control natural languages strike a balance between the usability of the natural language and the rigorous of formal languages. Control natural language enable analysis such as test case generation and model generation. Our evaluation shows that REMACE is expressive enough to capture most of the unseen requirements from the financial domain. Thank you very much for your attention.
Thank you, Alvaro, for the nice presentation. And I'd like now to call the second presenter. That will be Joseph Kekuru. I'm going to talk about PRASI, from package-based to call-based dependency networks.
Yes, so hello everyone. So my name is Joseph Heidrup. I'm going to talk about PRASI, from package-based to call-based dependency networks. This is work together with Moritz Beller, Konstantinos Triamfoulou, and Georgos Gousios, and this is a MC Journal First paper for this year. So probably many of you do have like a favorite CLI that you install your packages. Could be NPM, could be Cargo for Rust, etc. And most of us use it to be able to download packages that we can import in our software projects. And what is like very interesting briefly is that these repositories are quite large. So for example, you can see that for a very recent ecosystem like Craze.io for Rust, it's about average 66 new packages per day. In the case of NPM, we almost has like 2 million packages. It's about like 10,052 new packages. Packages are quite large and contain lots of third-party libraries. And in this study, so like in many previous studies on dependency networks or package repositories, they usually use a metadata-based representation. That is, if you see in the figure, for example, like the connection from app to lib1 and then to lib2. But what we were doing is that we were instead looking at a more fine-grained representation by looking into the function calls between packages as a way to understand how packages are reusing each other. And for example, I use cases, like vulnerabilities, which is quite a common one. So for example, if we do have vulnerability in the function intern, we can directly see that there is a reachable path. But for example, if there's a vulnerability in function unused, then we can directly see that there's no connecting path. But when it comes to metadata-based analysis, we will not find it, because we would always say that because something is vulnerable in lib2, then app is directly vulnerable because of it. And we were kind of curious, okay, so what if we, let's say, like use, let's say, like a call-based dependency network and compare that with a metadata-based network and see how things differ. So one sort of simple let's say like application is, for example, what is like the number of direct dependencies, right? So usually we would just like count the number of declared dependencies to it. And when we looked at it compared to looking at the number of calls to dependency, we found that when you look at direct dependencies, let's say like the approximation is similar. So if you declare on a dependency, most likely you are calling it. But then when we look at the number of transitive dependencies, the story is a bit different. So for example, like we looked at like the network, at Craze.io, let's say like in February, we found that, for example, when you use like the declared metadata, it will say that on average, you will use, let's say like 17 transitive dependencies. But then when you look at the call-based one, you see there's roughly 66 dependencies. So we found that most packages are not directly calling 60% of its resolved transitive dependencies. So sort of coming to the conclusions. So like when should you use, let's say like a metadata-based network? Well, when it comes to direct dependencies, but also let's say like if you want to build, let's say, like a call graph for every single package of a repository. It's quite some effort and not very easy to do in general, especially for, I mean, in the case of Creator or Rust, it has a very nice build system, so it's not so difficult to do it. But then also, as we know, for example, that a lot of package repositories, they're not a homogeneous collection of software. There are some packages that might use, let's say, like more code generation, use more like dynamic features, like reflection, for example. And then you might not have so sound packages, so sound representations, right? So when should you use, let's say, like a call-based network? And our reason is that you should always try to do it when you have, let's say, like when you want to analyze transitive dependencies. So the reason why is that if you look back to the other figure, one main problem is that like when you look at the functions that you call direct dependency, right? You call a certain number of APIs. And those APIs, let's say, like might not reach to all of the transitive dependencies. Sometimes when you call one part of the code, it doesn't mean that you directly call the other part of the transitive dependencies. And then another thing is that you have, let's say, like much better actionability, because instead of looking at the clear data, we actually look into the source code and can reason more about it. And another sort of important thing which I was trying to illustrate with the figure is that you have much better precision, because you can directly see what is actually, let's say, like being called and used in general. And yeah, this was like very brief overview. So if you want to know more about the work and etc., feel free to check out like the MC journal paper. Thanks a lot. That's yeah, all from me.
Thank you very much again, Joseph. I should remind people that the first paper and the second paper are journal first papers, and the next paper that we have in these sessions are technical papers from the conference. Our next speaker is Saad Azimi, and Saad is going to talk about handling of anaphoric ambiguity in requirements, a multi-solution study.
Hello, everyone. My name is Saad Azimi. I will present our paper, Automated Handling of Anaphoric Ambiguity in Requirements, a multi-solution study. First, I will start by reading this requirement specification excerpt from a developer point of view. The SNT component shall send all approval requests to the DBS. If the request contains storage parameters, it shall create a configuration record from the parameters. So in this small paragraph, to know what to implement, the developer must know which subsystem should create the configuration record in this case. First, I will define antecedents. Antecedents are the preceding entities that the pronoun refers to. In our case, the plausible antecedents for the pronoun it are the SNT component, all approval requests, the DBS, the request, and the storage parameters. So if we eliminate the obviously wrong ones, we still have two candidate antecedents that are left with two different implementations. We know that without domain knowledge, the developer is unlikely to correctly disambiguate the pronoun it. And in general, this is anaphoric ambiguity. So as we have seen, anaphora is prevalent in requirements. It occurs in around 25% in our dataset. It needs domain knowledge, which is not adequately captured by all involved stakeholders. So we developed and experimented with 6 solutions based on language models, machine learning, and off-the-shelf NLP tools. We empirically evaluated these solutions on 2 datasets. This is an example of anaphora problem formulation. The problem is composed from 3 components: the pronoun, context, and candidate antecedents. The pronoun is the problematic pronoun. In our case, it's pronoun it. The context are the requirement that contains the pronoun and the preceding one. Candidate antecedents are the preceding noun phrases that come before the pronoun it. In our case, we have 5 that we highlight in this case. So in our work, we handle ambiguity via 2 tasks. The first one is anaphora ambiguity detection. Its goal is to detect whether the pronoun is ambiguous or not. The second one is anaphora resolution. Its goal is to find the correct antecedents for a given pronoun. So our 6 solutions that we propose, the first 2 are based on span BERT, which is a variant of BERT language model that is optimized for span selection. The first solution, span BERT NLP, is fine-tuned on a large NLP dataset. Span BERT RE is the span BERT NLP that is fine-tuned again on a smaller RE dataset. The inputs of both models are context and pronoun pairs. The outputs are text spans with their prediction probabilities. For the 3 other solutions we have, they are based on machine learning. The first one uses language features that we gathered and enhanced from literature. The second one uses feature embeddings that we extract from sentence BERT. Machine learning ensemble combines both machine learning solutions in an ensembling fashion. The input of the 3 models are context, pronoun, and candidate antecedent triplets. The outputs are the candidate antecedents labeled with correct, incorrect, or inconclusive. The last solution is based on NLP coreference tools. We combine 2 NLP coreference tools that provide resolution for pronouns in a given context. We combine the outputs in an ensembling fashion. If both tools agree in the resolution, then the pronoun is deemed is unambiguous, and the resolution is the resolution that they provide. If they disagree, then the pronoun is ambiguous. So for evaluating our solutions, we use 2 datasets. The first one, DAMIR, which is our contribution that we built from 22 software requirements documents and 8 domains. It contains more than 700 pronouns. The second dataset, REC-Eval, is a public RE dataset. It has around 100 pronouns. In the first research question, we try to evaluate the or to find which solution alternative is the most accurate for anaphora ambiguity detection. So as we see in this table, machine learning based solutions are the notably machine learning ensemble technique overperform the other solutions. For the second research question, we evaluate the anaphora resolution task using 2 types of accuracy, full match and partial match. In our case, span BERT based solutions are the most performing here, and the span BERT RE is outperform span BERT NLP by a little margin. So in conclusion, we have seen the importance of anaphoric ambiguity requirements and how problematic it can be if left undealt with. Our findings reveal that language models do not always outperform traditional supervised machine learning methods in this task. And as we have seen, combining language models with machine learning in one solution is promising. Thank you, and that's all.
Thank you very much, Said. And I would like to call our next presenter, Ji, that's going to talk about Deep STL from English requirements to signal temporal logic.
Okay. Hello everybody. I'm Jehi from TU Vienna. It's my pleasure to present our accepted paper that promotes the application of formal methods in industry. Our work involves that translating English requirements into signal temporal logic to enable the compatibility between documented requirements and the input of existing runtime monitors. To this end, building a dataset and training an AI model constitute the main scope of our work. We started with an empirical study for both STL and English requirements in the literature. To adjust the scarcity of training data, we then developed a workflow to generate a parallel corpus, as shown in the 2 columns below. Then we employed a transformer-based AI model to train the translator, and then compared its performance with other models like seek-to-seek and attention. We also developed a specialized tokenization method so that votes in the corpus can be efficiently encoded. These slides show testing metrics of the translator. We firstly tested the trained models on synthetic data. We found that the attention model and the transformer, their accuracies are pretty high, with the transformer performing a little bit better. However, when we did extrapolation tests on real examples, so the translation accuracies of all models dropped considerably. Despite the loss of performance, we say transformer still does the best job. This slide shows the testing results of the transformer. As we can see, when the input language is very similar to the sentences in our dataset, the translation quality is very high, and the translator can also handle synonymous inputs. However, when the style of the input language is different from what have been trained, as can be seen in our extrapolation test, all models would probably make mistakes. In the first example, we can see transformer translates correctly. However, the attention model fails to copy the identifier and the number, and they even mistranslate the greater than relation into smaller. The seek-to-seek form model fails to translate anything. In example 2, transformer tends to add additional keyword called rise, while attention model would, however, reverse the meaning again. Still, seek-to-seek performs very badly. For example 3, transformer does the good job, but the attention model still makes the same mistakes. We think there are two possible future directions. The first is related to AI. We can see deep learning performs well when the testing data is similar to what have been trained. However, once the testing data is different from the training data, its extrapolation performance is very poor. This problem is not so obvious for general commercial tasks where there is a huge amount of training data. However, for industrial applications with limited data, how to build a more interpretable and accurate learning mechanism is an interesting direction. The second question relates to my own research experience in this paper. This situation is always more complex than what is conveyed literally. Taking me as an example, I suffered from gout, which may cause acute pain in the foot ankle, and nearly every medical guidance will require a man patient to limit his uric acid down below 6. If we know these requirements, can we be a doctor ourselves? Probably not, because we need a doctor to make the proper diagnosis according to comprehensive factors. So come back to the practice of engineering, which is also complex and needs professional knowledge. But in reality, what we obtained first is only industrial data sheet with fragments requirements. And sometimes without professional knowledge, we cannot even distinguish between what is a requirement and what is only a description. So I think RE may need to play a more proactive role in the whole life cycle of the Wei model. For example, we should distinguish what are the real important requirements in different phases, and are there any causal links? How to evaluate positive and negative results? How much tolerance can we accept? Obviously, we need the domain knowledge to know these details behind the context, as we need the doctor to treat the disease rather than merely relying on the guidance. Thank you very much for your attention.
Thank you very much, Ji. And I would like to call our next speaker, that is Yuwen Dong. He's going to talk about SNR, Constraint-Based Type Inference for Incomplete Java Code Snippets.
All right, can everyone see? Excellent. Hi, everyone. I'm Yuwen. This is my presentation about SNR, a constraint-based type inference technique for incomplete Java code snippets. Code snippets can be found in a variety of places: forums, Java docs, QA sites, like in the screenshot from Stack Overflow. Developers incorporate code snippets as part of their questions to help clarify what they're asking for and get more specific help. And oftentimes people will also respond with code snippets to help illustrate their answers. But the problem with these code snippets is that they're generally incomplete. First, code snippets are generally syntactically incomplete. For this code snippet, we wrapped it with a class and method declaration to make it parsable. But this code snippet is still missing type information. We highlighted some of the missing types like date format, date calendar, These short names allow the code to be written more concisely, and the fully qualified names for these types are generally specified in import statements, which are not here, nor is there any library information here to help guide us. Here's the code snippet after the import statements are added, and this code snippet is finally adapted for real-world use. In general, these challenges make it hard to reuse code snippets from the internet. In this work, we focused on using type inference to infer the fully qualified names of the types found in the code snippet, and use that to add the import statements to make the code compilable. Our unique insight for this work is to leverage partial semantics of the code rather than resorting to machine learning-based approaches for type inference. Let's look at an example. Here we have a line from the code snippet before. From this line of code, we know a number of things. We know that calendar is a type with a simple name calendar, that this calendar type has a method getInstance that takes 0 arguments and returns a type with a method getTime that takes 0 arguments. And the return type of getTime is a subtype for the type of the variable today, and today has a type with a simple name date. We can leverage its knowledge to help us infer the types in the code. We annotate the AST with the type variables to show all the types used in the code snippet. Using the type variables, we can translate the earlier knowledge to these 5 constraints, like tau2 has simple name calendar, method getInstance with no arguments, return type of tau3. GetTime method is similar, subtype constraint where tau4 is a subtype of tau1. And we just need to solve for the type variables. To help solve for the type variables, we leverage a knowledge base, which we built from popular Java libraries, such as the JDK, JOLATime, and more. In this sample, we can see there's a calendar class with methods getInstance and getTime, which returns calendar and date. And there's a couple classes with a simple name date. These facts can help us solve the constraints from earlier. The knowledge base, in addition to storing methods and fields, also contain relation information shown in this simplified schema. So with the constraints and the facts from the knowledge base, they can be fed to a data log system, which give us a mapping from the types in the AST to the fully qualified names of the type which satisfy these constraints. Using constraint-based type inference, we can safely rule out java.sql.date as the type for the variable today, as it will violate the subtype constraint since getTime returns util.date. To evaluate the performance of SNR, we gave 267 code snippets without import statements to get a mapping between the API elements and the top 1 recommendation for their fully qualified names. Using that, we calculated the precision and recall of our tool. And we found that compared to existing state-of-the-art tool Coaster, published in ASE 19, which uses machine learning-based technique, that SNR outperforms Coaster with very high 98.2% precision and 79.66% recall. In summary, we introduced constraint-based type inference, a technique to automatically conduct type inference with our unique insight of using partial semantic information on code snippets. We evaluated our technique and found SNR outperforms existing state-of-the-art with high precision and recall. Thank you all for listening, and please check out the paper for more information. Thank you.
Thank you very much again for a very interesting presentation. First of all, I'd like to thank all the presenters for inspiring and very interesting work. And after that, I would like also to open the chat for questions. I took the liberty of a couple of questions, but please, I'll ask the presenters and the audience to start asking questions. While you prepare your questions, maybe I'll start by asking a question to Alvaro. Why only functional requirements?
Okay. Our industrial partner, we work in collaboration with an industrial partner, and we ask them to provide software requirements specification that they contain requirements. We analyze the requirements, and the majority of them were functional requirements. We confirm that with our industrial partner that they mostly use functional requirements for describing their requirements. That was the main reason that we didn't consider non-functional requirements, because we didn't have enough data points where we can extract data structures to build our language.
Okay, but do you believe your work can be expanded for non-functional requirements?
Yes, in our paper, we describe in detail our methodology to extend or to create control natural languages, and yes, we believe that it could be a good starting point for creating control natural languages. Not only functional requirements, but also non-functional requirements.
Okay, thank you. I see Mark has a question and it just came on screen, so you can unmute and ask the question directly.
Can you
please.
hear me? Can you hear me? Excellent. Thank you so much all for the great presentations. I have a question for G. We have been trying to actually apply this transformation from natural language requirements to some form of temporal logic. And very similar to what you were doing, I was very pleased to see the good accuracy overall. What I was a little bit puzzled by was, the rather simple structure of the sentences. And what we've often observed in real applications is that, there might be variable names that are missing. You don't really have these templated requirements that start very cleanly to suggest that you have a conditional, for example, included at the beginning. So there are a lot of variations in how these requirements, in the form that the requirements may come in. So I'm wondering what your experience is, and how does the approach cope when you drift away from the template-looking requirements that you have?
Okay, thank you very much for your question. So, basically, our research, our paper only considers the clear requirements. So it's very strict meaning of what the temporological means, and what we mainly focuses on is synonymous expressions. So we have found that in our literature review, maybe 30% of requirements are like these clear ones, and there are 70% is like what you have said, very indirect and ambiguous, and even an expert needs a lot of time to translate them. So I think maybe if we use deep learning next time, maybe yes, we can use although what have generated is a little bit strict, not so flexible. Maybe we can use some automatic data augmentation method in NLP to enrich the expressiveness of the English language. But if we say we want to translate very indirect or something ambiguous language, maybe I think the pure end-to-end translation, I think maybe because it's very hard to pre-process such kind of data sets. So maybe based on traditional NLP method like rule-based or knowledge-injected method in this, maybe handle the translation procedure. But I think it's still very hard job to do. Yes.
Thank you. I think my issue was that in reality, usually that 70% versus 30% that you mentioned, this is the ratio one would expect, at least with the existing techniques, whether it works or it doesn't. So that answers my question. Very Very helpful.
Yeah,
Thank you.
yes, as I want to add more is that some, because I'm focusing on electronics and industrial applications, so some requirements need very deep understanding of the business of electronics design or robotics design. So if we do not need this background, it's also very hard for us to understand what they are saying. So this is my personal experience, so I put it into the second direction. Yeah.
Excellent. I have one comment, but I'll let others ask questions, and if there is time, then I'll come back to your presenter. Thank you.
Okay, thank you very much.
Okay, thank you, Mehrdad. I have a question to Saad. What is the average that you found in terms of percentage of anaphora in requirements? Did you do any analysis of that?
Yeah. In our data set, we analyzed around 5,000 requirements. And we found around 25% of them contains anaphora.
Okay, and the types of anaphora is not only the it pronoun.
No, it was only for showing the example. We handle all types of pronoun. So we handle a pronominal anaphora to be precise, not only third-person pronouns, but all pronouns.
Okay, thank you. And I think we have now a new question from Diksha Arya, and it's for Ewan. I don't know if Diksha, if you'd like to turn on your video and your microphone, you can ask directly. I don't think so. Okay, no problem. So we are going to read your question. Interesting work. Can the type inference handle overload the keywords and libraries based on context? Example, assert can be sourced from the assertions library or the JUnit library.
Yeah, interesting question. So if we use constraint-based inference, so if there is some say method that's in the assert library that's not in the JUnit library that was used in the code snippet, then of course we'll say, okay, this method's not there, so it must be from this library. Then we'll be able to infer. If say they have the exact same methods and they can be dropped in place with one another, then it'll be a little more difficult. But our technique ensures that only one such library will be brought in instead of say both, and create conflicts in the class path. I hope that helps answer the question.
Thank you. Mehrdad, I think you had wanted to make a comment. Maybe you can do it now.
Type it in, but yes, actually there are two. There is work on requirements demarcation that G might find helpful. Basically, he mentioned this problem of differentiating between what is a requirement, what is a description, what is an example. So there is some work in the RE community trying to do that using AI. And then another interesting bit is the work that has been done recently on extracting invariants from Javadoc, for example, where you have a very large volume of very nicely written set of documents. So these two are quite relevant to what you've been doing, different types of logic, obviously, but that might also be a very nice thing to look into. Yeah.
Thank you very much.
I'm really hoping that this thread of work that you've started will pick up. There is a lot of value there, and I'm obviously interested in where this is going. So looking forward to the next steps.
Okay, thank you very much.
Take care.
Thank you. Any more questions? No comments?
There's one in chat.
There's one. Oh, yes. G is asking also. G can ask directly, no? G?
Okay, so I directly ask, right? So, I'm curious about how flexible the input language can the NCNL approach handle. So sorry, a typo. So one reviewer also mentioned this to us. So why they asked us why we not consider this CNL approach. So because I'm new in the requirements engineering, so I would like to ask: is CNL a common approach in practice?
Thank you for the question. There are different approaches that tackle have been used to improve the quality of the requirements. We decided to use control natural languages because apart from restricting the syntaxes, they also restrict, we can also define precisely the semantics, and this allow us to find more easy the content information towards the test, towards the task automation. We also have a work where we use this language, our language, in order to generate acceptance criteria from textual requirements.
Yeah, thank you very much. So another question is that I asked shortly yesterday is you spend a lot of time, months to collect this data. So how is it doable for you? So is there a company collaborated with you, or you just want to search these requirements in the literature? So yeah, so I'm curious about the source of the data. Yes.
Regarding the source of the data, was I couldn't listen completely your question because I don't know whether I have communication issues here. But your question is regarding the source of our data set.
Yes.
Okay.
So I'm curious about the procedure, how to collect this data, because it's very time consuming and.
Yes, we work with a company, and this company provided us Word documents and PDF documents that they contain that they contain requirements. So we analyze the structure. Fortunately for us, they delimit with a certain type of structure where they define the requirements. So we take advantage to collect automatically from these specific parts from the document the requirements. So this process for us was automatically because our industrial partner uses a template, and this template separates easily the requirements from the other text.
Okay, I understand the approach. Thank you very much.
You're welcome. Thank you for the question.
I believe you're not supposed to say the name of the industrial partner, at least the domain. Are you able to say the domain of the data that you receive from the industrial partner?
It belongs to the financial domain. So we work with a company
you
here in Luxembourg.
Before. Okay.
Yes.
Thank you. I think Saad has a question.
Yes, I have a question for G.
Okay.
If I understood correctly your work, so you generate from formulas. Oh,
yes.
Well, you start by generating randomly some formulas, right? Then
yes.
you transform these formulas into text, into requirements.
Yes.
Using some templates, and you pick randomly some ones that you have a variety of data.
Yes.
Since all your data is synthetic, how do you deal with the machine learning models overfitting on your data, on the synthetic data, and then when you give it real world data, it doesn't perform well. So how do you tackle the overfitting problem?
Currently, this is a very hard problem for us because nowadays, when we first do this project, there's no such kind of parallel data. So I generated in our basically a template approach. But as you can see, what I have generated is very close to the language, a little bit flexible language. But as you mentioned, the overfit problem is still a very huge problem. So because we only have a limited number of data, so once the testing case is not similar to what we have trained, so the overfitting problems will be very prominent. So currently, if we purely rely on deep learning, this problem is very hard to handle. Except that we can have very flexible expressions of the requirements. So
since you use formulas or templates for requirements, so if the models receive like lots of similar texts in that is following some templates, I suspect that they will always overfit, I would say. But something that you can try is some paraphrasing over these requirements, so you can change the form, and then maybe you will tackle this overfitting problem.
Yeah, exactly. So I will first next step maybe to do automatic data augmentation methods. And I'm also curious about how to use some traditional NLP techniques to, for example, syntax analysis and semantic analysis, not purely relying on the end-to-end deep learning approach, so that we can have more clear information of the requirements, because the requirement language is not that flexible than as the natural language. It still has some structure and some keywords. So maybe this kind of information can be utilized.
That's true. Sometimes language features or language techniques can outperform deep learning.
Yes, exactly.
And in your work, you translate formulas into natural language. Since you have the data, do you think of doing the opposite, like translating natural language into formulas?
What our task is just to translating natural language into formulas. But when I prepare this data set, it is more easier to do a reversed way. So I first randomly generate a data set, a formula, and I found this. Yes, this to yes.
Okay, thank you.
Thank you very much.
Thank you. Any more comments or questions?
I have a question.
Please.
Yeah. So how is the call graph created? Did you observe any inaccuracies in the generated call graph, and what impact of that?
Could you please repeat? I couldn't hear properly.
Oh, sorry. Yeah, like how is the call graph created in your work, and did you observe any inaccuracies in the generated call graph, and what's the impact of that?
Just with me, right? Yeah, so with the call graph, so what we decided here is that because we are like trying to build call graphs for like, I think it was like for around 30,000 packages, probably amounted to around like 90K releases. So we were focusing more on trying to have it scalable rather than focusing having the most precise call graphs. Of course, we did have some imprecisions. So that's mainly, let's say, like that we didn't deal with, for example, function pointers. And also, like the algorithm that we used is more class hierarchy analysis. So that's more like basically trying to understand, like, like first of all, like static dispatch, but then like virtual dispatch. So like, what are like the possible implementations of a function that you can call? So it's more or less like around that level. Yeah, so that's pretty much it. Yeah.
Thank you.
Thank you. You, I have a question for you. Your work is to infer types, but can you infer other, okay, have you consider inferring other aspects of the code?
Sorry, I think you cut out a little bit from me.
Your work is inferring types from the code, but is it possible to use to infer other aspects?
Infer other aspects. What other aspects would you?
That's the question. If so,
Right. So, yeah. So we had to infer aspects such as if it's a variable or if it's a type reference. Say in the example I have earlier, if calendar, someone had a variable called calendar. If that would be a class, it's a variable name. So that's something we had to do. And I think some trivial extensions to our current inference could also detect if a variable is used but it was not declared, which is kind of common in Stack Overflow code snippets. Yeah, that's currently what I can think of off the top of my head.
okay. Thank you. Any more questions? There are other people in the audience. Please don't be shy and ask questions.
I guess I can do a follow-up question to.
Okay, please.
So if you remove the unused library, will the program still run? Have you tried?
Repeat the question. I didn't hear.
Sorry. So if you created this call graph, if the unused libraries are removed, will the program still run? Do you think?
So remove what? Someone like I'm not hearing properly.
Unused libraries.
Unused libraries. Yes. So actually, like when we built a Overgraph network, so when we're doing the evaluation, we would often find that sometimes libraries are not presented, right? So I think the challenging part with static analysis is that it could either be that it's unused or it's an imprecision in your analysis because you're not able to like find out. And that can sometimes happen. So let's say like if I would have like a package that only does function pointers, something that our call graph library won't handle, right? Then we will miss a lot of functions. But in general, I mean, I would say that since also according to the Rust language documentation, they say that function pointers is not widely used. So I don't think it's like a major issue. So I mean, we did find in many cases like that. Yeah, like that the APIs are not used in general. And that's also like a very, very interesting thing. So I see like in many cases that although like we might depend on some large libraries, we only might be calling like 5-6 APIs of it. But then like there might be like 30-40 other APIs that are not used.
Right. Thank you.
Yeah.
Thank you. Any other question? Okay. So if you don't have any other question, perhaps we can take the opportunity to thank again all our presenters for their nice work.
I think he has a question.
Okay, please.
Yes. So my question is, what's okay to the two presenters? So what's your plan for your plans for the next step for handling data sets? And it seems that in requirements engineering, so it is a very data centric. And normally we lack this huge amount of training data as in the AI community. So are there any? So what's your plans for handling this kind of lacking data set problem?
This is to Alvaro and to Sam, correct?
Yeah. Indeed, there is this lack of data in requirements in general. In our current research, we do some data generation, which is based on language models, which can be also good for some tasks. And it can be considered as an aspect of data augmentation. It can work, I think, as well for your case. If you feed your data or to a pipeline that does data augmentation, it can enrich your data to have like a bigger data set that can enable you to train powerful models or do other solutions.
Yes. So yes, you also think about that. Okay, thank you very much.
Yes, well, answering your question, yeah, it's true that we don't have many data points, many requirements. Also, in our case, having not many requirements prevent us to use other type of technologies, such as grammar induction, where you can apply kind of but for applying this type of techniques, you need a lot of data. That was one of the points that prevent us to use these approaches. Because for example, for building our grammar, we had around 2,700 requirements from the financial domain. It's not a big number. Also, for example, for some structures, we have few we have few data points, but for other type of structure, we have a lot of data points. So we have we have an imbalance data set. Yes, and it's a problem.
Thank you very much. So are you graduating soon?
Yeah, as Merda said, I hope you graduate soon.
Yes, both of our answers are very, very close. Yes, within months.
Yeah, we have very excellent research in this conference.
Exactly. Good. So I think you should again thank everyone and wish everyone good luck in the graduation and the continuation of the work. And hopefully we'll see you at the conference in the next couple of days as well. Thank you. Thank you for all the presentations.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.
Thank you, everyone.